Today's topic is adding and subtraction of polynomials. So there are a lot of terms, as you can see on this document, that we are going to talk about. So a polynomial in one variable, such as x, is defined as a single term or the sum of the terms in the form a times x to some power, where a is a real number and n is the exponent, which is a non-negative exponent. Recall, you can only have negative exponents when you're dealing with scientific notation. For each of the terms, it is a product. So you have a, which is the coefficient, and n, which is called the degree. So you might have 4x to the third power. 4 is the coefficient, and 3 is the degree. So the number in front is the coefficient, and the exponent is the degree. Now, a monomial is a polynomial that has exactly one term. This is a monomial, one term. It's the multiplication of a coefficient and a variable or variables. Now, you could have 1/2 xyz. It doesn't have to be just one variable. It could be multiple variables, but it's all being multiplied together. 1/2 times x times y times z. There's no addition or subtraction in that term. Now, a binomial has exactly two terms. This is when you start pulling in addition and subtraction. So you could have x plus 4. You could have y minus 6. Two terms. You could have 3x squared minus 6. Those are all examples of binomials. Notice that I have one term plus a second term, first term minus a second term. 3x squared is considered a term, and 6 is a term. Now, a trinomial has three terms, exactly three terms. So it could be a plus b plus c. It could be 3x squared minus 6x plus 2. As long as it has three terms that you are either adding or subtracting from each other, that would be a trinomial. Now, the term with the highest degree is called the leading term, and its coefficient is called the leading coefficient. So we'll look here. This is the leading term because the degree of 2, the exponent of 2, makes it the highest degree. Now, the coefficient is 3 because it is the leading coefficient. It's the number attached to the term with the highest power. Now, the degree of a polynomial is the greatest degree of all of its terms. So in this case, the degree would be 2 because that's the largest exponent in that problem. Now, if a polynomial has more than one variable, the degree is the sum of the exponents. So like if we had 4x squared y plus 6x squared y to the third, the degree would be 5. Because if I add these two exponents together, I get 3. And if I add these two exponents, I should say exponents on the variables, I get 5. The larger value is 5, so the degree of that polynomial would be 5. Now, in example 1, it simply wants us to write this polynomial in descending form. What that means is you want every term in order from the term with the largest exponent, down to the smallest exponent, or the constant term, which is a term that does not have a variable. So the largest exponent I see is c to the fifth. So I'm going to write down my negative 10c to the fifth first. So I've got that accounted for. The next exponent I see is a third. So minus c to the third. Then I have my 8c squared and my positive 8. And so if you notice, I go from c to the fifth, c to the third, c squared to a constant term. That would be writing a polynomial in descending order. Now, In the next exercise, we want to categorize the expression as a monomial, binomial, or trinomial, and then identify the coefficient and the degree of the leading term. Now, this has two terms, 5c and negative 3c to the third. So two terms means it's a binomial. That answers the first question. Then identify the coefficient and the degree of the leading term. Well, the leading term is not 5c. If I rewrite this, the leading term, if I write this in descending order, the leading term would be negative c to the third power. So the leading coefficient, in this problem would be negative 1 because that's the value in front of the leading term. And the degree of this polynomial is the largest exponent, and that would be 3. Now, if you look at example 3, there's only one term. But if you notice in that one term, which means it is a monomial, there's no adding or subtracting going on in that problem like there was in number 2, where you had one term minus a second term. Now, to identify the coefficient, that would be 7. The leading coefficient would be 7. And the degree would be 2 plus 3 plus 1. You add up all the exponents, so the degree would be 6. I don't physically see a 6, but I get that 6 by adding up all the exponents in that term. Now, in the fourth example, the first thing I'm going to do is write it in descending order. So 3y squared plus 6y minus 5. That is a trinomial. It has 3 terms. The leading term is 3y squared. The leading coefficient is 3, and the degree is the exponent 2. If you have any questions about that, please make sure you let me know. Now, there are 2 different ways that you can add polynomials together. So if 2 terms are like, they have the same variable and the corresponding variables are raised to the same powers. So in order to add polynomials, you need to be thinking, I need to group my like terms, and then I combine the like terms by adding their coefficients. Notice it does not say anything about changing their powers or their exponents. You just need to add the leading numbers, the coefficients out in front. So 5a and 5a to the third are not like terms. They are not like terms because the variables are not raised to the same power. That is why 5a and 5a to the third are not like terms. Now, in order to add polynomials, we need to group the like terms together, and then we need to add their coefficients. So if I look in this group and this group, I'm going to group my a's together, 5a plus 3a, and then I'm going to group my b's together, plus 3b minus 7b. I'm going to add and get 8a. I'm going to subtract and get negative 4b. I added those coefficients, the 5 and the 3, to get the 8. I added the coefficients 3 and negative 7 to get the negative 4. Now, in the next example, I'm going to add up my x squares, I'm going to add up my x values, and then I'm going to add up my constant values. Now remember, constants are the ones with no variables. So 4x squared minus 6x squared. Then I'm going to take 8x and subtract x from it. Then I'm going to take my negative 6 and I'm going to add 9 to it. When I add these two terms together, 4 minus 6 gives me negative 2x squared. Notice that I'm only changing the coefficients. I am not changing the exponents at all. When I add these two together, 8 minus 1 is positive 7x, and then negative 6 plus 9 is positive 3. And that would be my final answer. You can even do that with the coefficients of fractions. So I'm going to add my c's together in this problem. Number 8, I'm going to add the d values together, and I'm going to add the constant values together. So I'm going to take 3/4 c and add it to 1/4 c. I'm going to take my 1/5 d, and I'm going to add that to 2/5 d. And then I'm going to take my negative 3/8 and subtract 1/8 from it. When I add 3/4 and 1/4, I get 4/4. So I get 4/4c, which just becomes 1c. When I add 1/5 and 2/5, I get 3/5 d. I can't reduce that or divide it out, so it stays. And then negative 3/8 minus 1/8 is negative 4/8. I can reduce that to negative 1/2. And that would be my final answer for number 8. Now, some people like to line up their terms, and that's okay. So in this problem, I'm going to add straight down. I do not have any other g to the third terms. Then I do not have any other g squared terms. I am going to add these two together, just add straight down, and that gives me, I apologize, I left off part of that squared term. So let's go back and fix that, 3.4 g squared. When I add 1.2 and 2.4 g, I get 3.6 g, and then negative 6, add straight down that column, and negative 2 give me negative 8. That would be the final answer for number 8. Now, most people don't like to set it up that way, but if that is the way that you like to do that, by all means, you can do that. Now, when it comes to subtraction of polynomials, the opposite of a polynomial is to find the opposite of the polynomial. I've lost my thought. I apologize. The opposite of a polynomial is basically changing the sign. It's also equivalent to just simply multiplying it by negative 1. So to find the opposite of, or to subtract polynomials, you will find the opposite of the polynomial being subtracted and combined like terms. So if I had 16, the opposite of 16 would be negative 16. If I had the polynomial 3x minus 4, the opposite of that would be negative 3x plus 4. Notice how all the signs have been changed. So in example 10, what we're going to do is we're going to find the opposite. It does not ask us to do anything else. It simply says to find the opposite. So the opposite of 3r minus 15 would be negative 3r plus 15. The opposite of the problem or the polynomial in number 11 would be positive 4x to the third minus 3x squared plus 6. Now what we're going to do when we get down to 12 through 16 is we're going to rewrite this problem by adding the opposite, just like you would in a normal subtraction problem. So the first parentheses, I have 6a minus 5. That negative goes across. That negative tells me to find the opposite. So I'm going to take negative 12a and negative 5. The opposite of positive 12 is negative 12. The opposite of positive 5 is negative 5. Now, I'm going to go through and combine like terms. There are no other a squared terms. There are no other a terms, but I can add my two constant terms together and end up with negative 10. In number 13, I'm going to take that negative and I'm going to go across and I'm going to change all those signs and create the opposite. So 5x squared or y plus the opposite of a negative is positive. Then I have negative 2xy and I have negative 3. So the opposite is positive, the opposite is negative, the opposite is negative. Now, the only two terms that I have that are like are the first two. They are both x squared y terms. So I'm going to add the 5 and the understood 1, and I'm going to get 6x squared y. I do not have another term with just x and y, and I'm going to write down my constant values. That would be my final answer for number 13. Now, in number 14, before I do anything else, I am going to find the opposite of these values back here. So I have 1/4 g squared plus 2/5 g minus 3/7. Then I'm going to change all these signs to the opposite of what they are. So that would be negative 3/4 g squared plus 1/5 g plus 2/7. So I can add 1/4 minus 3/4. That gives me negative 2/4 g squared. I'm going to add the coefficient of g. So that gives me 3/5 g. And then I'm going to add the two terms at the end, which are constant terms that have no variables with them. So I'm going to add the negative 1/3 to the or negative 3/7 to the positive 2/7, which gives me negative 1/7. Now the only thing that I need to do is I need to reduce that fraction. So my final answer would be negative 1/2 g squared plus 3/5 g minus 1/7. Now, number 15, that tends to be a little bit more difficult if you write it down in the column format, because this tells me that I need to add the opposite of this bottom row. So I'm going to keep the top row exactly as it is. I'm even going to leave the space. Now, I need to distribute that negative all the way across. So that would become negative 2.4 y to the third. Leave a space here. That would become negative 4.8 y and positive 2.1. Now, when I draw my line, I add straight down. So when I go down and I add 1.2 and negative 2.4 is negative 1.2 y to the third. This term will come straight down, negative 2.3 y squared. This will come straight down, negative 4.8 y. And this term, when you add those together, you get 5.2. That would be your final answer for number 15. Now, you can do this with more than one polynomial. So what we're going to do is we are going to simply take that negative and distribute it. So when I write this problem down, that's going to be 12w to the third plus 3w minus 6. When I take that and find the opposite of all these terms, that would become positive w to the third, positive 4w squared, minus 3w minus 8. Then I get positive w squared minus 7w plus 1. Now I'm going to go through and add up all my like terms. So I have a w to the third and a w to the third, which gives me 13 w to the thirds, because 12 plus 1 is 13. So I've dealt with my w to the thirds. I do have some w squares, so I have a w square here. That gives me 5 w squared when I add up my like terms. So my squares have been accounted for. Now, I have 3 w's. I have 3w, negative 3w, and negative 7w. Now, the 3 minus 3 is 0, and 0 minus 7 is negative 7. And then I add my negative 8, my 6, my negative 6, and my 1 together. So when I add all those numbers together, I get negative 13. Now, for number 17, it simply wants us to find the difference. So we're going to take negative 2t squared plus 3t minus 4. We're going to subtract negative t squared minus 4t minus 4. And then I'm going to go through and I'm going to find the opposite of this. So that would be negative 2t squared plus 3t minus 4. Then I get positive t squared, positive 4t, and positive 4. Now I go through and add up my like terms. Negative 2 plus 1 is negative 1t squared. 3t and 4t, that give me 7t. And negative 4 and positive 4 cancel. So my final answer for number 17 would be negative t squared plus 7t. If you have any questions about that, please let me know.